Hey everybody, welcome to your first lesson in Unit 5, which is our unit on cognition. And we are moving into building on sensation and perception, and this lesson is going to be focused on memory. So we're going to start off with, how is memory defined? Memory is the persistence of learning over time through encoding, storage, and retrieval of information, and we're going to really pick those apart. Research on memory's extremes has helped us understand how memory works. Some disorders, such as Alzheimer's disease, slowly strip away memory, and at the other extreme are people who would win gold medals in a memory Olympics. Alzheimer's disease is a progressive neurodegeneration and fatal condition. So if you look at this diagram, you see on the left-hand side a healthy brain, and on the right-hand side a severe Alzheimer's disease, a brain of a patient with severe Alzheimer's. Alzheimer's disease begins as difficulty remembering new information and progresses into an inability to do everyday tasks. Family members and close friends become strangers, complex speech devolves to simple sentences, and the brain's memory centers weaken and wither. So what about the other extreme? Russian journalist Solomon Shershevsky, or S, had merely to listen while other reporters scribbled notes. S could repeat up to 70 digits if they were read about 3 seconds apart in an otherwise silent room. He could recall digits or words backward and easily as forward. Crazy. How is memory measured? So there's 3 ways memory is measured: by recall, recognition, and relearning. So recall is the retrieving of information that's not currently in your conscious awareness, but that was learned at an earlier time. And that makes sense. You're recalling something that was learned at an earlier time. You can't recall it if you've never learned it. Recognition is identifying items previously learned, and relearning is learning something more quickly when you learn it a second or later time. So how do we measure memory on tests in school? This is a good way to give you an example of these 3. So recall, an example of that would be a fill-in-the-blank question, short answer, or essay prompt. Recognition would be something like multiple choice or matching. And relearning example would be something like studying for a final exam over the entire year's course content. How do we measure memory in life events? Recall, telling your friend about the time you won a goldfish at a carnival. Recognition, seeing a brand of cereal on the grocery shelf and recognizing it from a commercial. And relearning, traveling to Costa Rica and pulling back the Spanish you learned from Don Andres in 10th grade, or 9th or 8th or 7th or 11th or 12th. So how did Hermann Ebbinghaus test speed of relearning? Pioneering memory researcher Hermann Ebbinghaus randomly selected a sample of syllables like those you just saw, practiced them, and tested himself on his ability to accurately recall the items. Actually, you didn't just see them because I deleted that slide because it's not, we're going to use it in the lesson check-in. So the day after learning such a list, Ebbinghaus could recall few of the nonsense syllables, but they weren't entirely forgotten. So what were Hermann Ebbinghaus's findings? Ebbinghaus found that the more times he practiced the list of nonsense syllables on day 1, the less time required to relearn it on day 2. Speed of relearning is one measure of memory retention. So as rehearsal increases, relearning time decreases. And I know you guys, especially you guys who have had me multiple times, I have said so many times that you need to hear, say, see something at least 8 times in order for it to sink in. That goes back to Hermann Ebbinghaus's findings. How do psychologists describe the human memory system? Psychologists propose an information processing model which likens human memory to computer operations. To remember any event, we must do 3 things. We must encode it, which means put in new information. We must store it, which means organize the information that we just encoded, and then we must retrieve it, pull out the new information when we need it. What is parallel processing? So considering many aspects of a problem simultaneously, the brain's natural mode of information processing for many processes. So when we consider many aspects of a problem simultaneously, so the simultaneous is the key word to help you remember parallel processing. How does parallel processing function? This is something we learned about in Ignore Module 18, but we learned about it in an earlier lesson in sensation and perception when we were talking about vision and how our eyes see things and how our eyes process. So that when a person sees an object, they don't just see one thing, but rather many specific aspects that combined allow the person to identify the object in its entirety. So first you see a bird in motion. You know that it's moving, and then your brain sees its form. So first it sees that it's moving, then it sees its form, and then it starts to see depth, and then it starts to process color. So all of those things give you the final version of the moving bird. What did early models of memory formation look like? Richard Atkinson and Richard Schifrin proposed a three-stage model of memory. Sensory memory, short-term memory, and long-term memory. We're going to spend a little bit of time on these. First, we need to just define what they are. So sensory memory is the immediate, very brief recording of sensory information in the memory system. Short-term memory is memory that holds a few items briefly before the information is stored or forgotten. And long-term memory is relatively permanent and limitless storehouse of the memory system. How have early models been modified? So today's researchers recognize other ways long-term memories form. For example, some information slips into our long-term memory via a back door without our consciously attending to it, which is automatic processing. So much active processing occurs in the short-term memory stage that many now prefer the term working memory. Because much of the active processing occurs in the short-term memory, it's not long-term, rather it's working. Working memory is rehearsal and active maintenance, working/short-term memory. And that leads to encoding, which leads to long-term memory storage. And then from your long-term memory storage, you use retrieving to gather information from your working short-term memory. So what is working memory? Working memory is a newer understanding of short-term memory that adds conscious, active processing of incoming auditory and visual information and of information retrieved from long-term memory. So think back to sensation and perception 2 units ago, the unit before learning, and we spent a lot of time on how we process auditory and visual stimuli. So with auditory rehearsal, you have an example of mentally repeating a password long enough to enter it online. Central executive focuses our attention, and visual spatial information, mentally rearranging furniture in a room. So you've got your auditory and your visual both go to central executive, which focuses our attention, and that leads into long-term memory. How does Baddeley's model address working memory? So Alan Baddeley, 2002, he had a model of working memory that includes visual, spatial, and auditory rehearsal of new information. A hypothetical central executive, which is like a manager, focuses our attention and pulls information from long-term memory to help us make sense of new information. The role of the central executive is key to the new model. The role is that it coordinates focus processing, without which information often fades. So that leads us into explicit and implicit memories. So explicit memories, retention of facts and experiences from long-term memory that one can consciously know and declare. These are also called declarative memories. Implicit memories are called non-declarative memories, and they are the retention of learned skills or classically conditioned associations in your long-term memory, independent of conscious recollection. So how do those two things differ? What does that really mean? So we encode explicit memories through conscious, effortful processing, encoding that requires attention and conscious effort, whereas implicit memory is automatic processing. It's unconscious encoding of incidental information such as space, time, and frequency, and of well-learned information such as word meanings. So, what does that mean? Space, time, and frequency. What information do we process automatically? So this was implicit. Can you remember the page or side of the book certain charts, graphs, or material is located? Or if I asked you to remember where the restore jobs are located or where the core values are posted in certain classrooms, could you remember that? That's an example of space. Time, have you ever retraced your steps through the sequence of your day to find a lost item? And frequency, can you recall how many times today you have run into a good friend? What was George Sperling's sensory memory experiment? So when George Sperling, this is an experiment from 1960, flashed a group of letters similar to this for 1/20th of a second, people could recall only about half the letters. But when signaled to recall a particular row immediately after the letters had disappeared, they could do so with near perfect accuracy. This is sensory memory experiment. So in a particular row, so KZR, QBT, SGN, they could repeat it with near perfect accuracy, but they could not recall the actual letters when looked at as a whole. So what is iconic memory? Sperling's sensory memory experiment demonstrated iconic memory, which is a fleeting sensory memory of visual stimuli. That's what we just did. For a few tenths of a second, our eyes register a picture image memory of a scene, and we can recall any part of it in amazing detail, just a part of it. We also have an impeccable, though fleeting, sensory memory for auditory stimuli called echoic memory. Picture yourself in class as your attention drifts to thoughts of the weekend. If your mildly irked teacher tests you by asking, "What did I just say?" you can recover the last few words from your mind's echo chamber. Auditory echoes tend to linger for 3 or 4 seconds. How are short-term and working memory related? So recall that short-term memory refers to what we can briefly retain. The related idea of working memory also includes our active processing, as our brain makes sets of incoming information and links it with stored memories. Well, what are the limits of what we can hold in this middle short-term stage? What's our short-term memory capacity? George Miller in 1956 proposed that we can store somewhere between 5 and 9 pieces of information, often referred to as 7 plus or minus 2, in short-term memory. Other researchers have confirmed that we can, if nothing distracts us, recall about 7 digits, but the number varies by task. We tend to remember about 6 letters and only about 5 words. How fast do short-term memories disappear? Psychologists Peterson and Peterson asked subjects to remember 3 consonant groups such as C, H, and J. Without rehearsal, after 3 seconds, people recalled the letters only about half the time. After 12 seconds, they seldom recalled them at all. What is our working memory capacity? Working memory capacity varies depending on age and other factors. Compared with children and other adults, young adults have a greater working memory capacity. What's the benefit of a large working memory capacity? Well, having a large working memory capacity means the ability to juggle multiple items while processing information. It tends to aid information retention after sleeping and creative problem solving. So what are some effortful processing strategies that can help us encode and retrieve? There's 3 things: chunking, mnemonics, and hierarchies. Several effortful processing strategies can boost our ability to form new memories. Later, when we try to retrieve a memory, these strategies can make the difference between success and failure. And we use these strategies all over the place in teaching. So look out for how in your classes you chunk, use mnemonics, and use hierarchies without even knowing you're doing it. So what is chunking? Chunking is organizing items into familiar, manageable units. 16 items would be too much for the short-term memory or the STM to hold, but chunked into 5 meaningful items fits the 7 plus or minus 2 capacity of short-term memory. Were you able to recall the letters easier when chunked or grouped in the second way? So you have the first way, and then you have the second way. The second way are probably 3 or 4 letter combinations that you can associate with something else, which we'll get to a little bit later in the lesson. What's a mnemonic device? Memory aids, especially those techniques that use vivid imagery and organizational devices like acronyms or acrostics. We more easily remember concrete visualizable words like bicycle or book than we do abstract words like peace or love. Paper towels, 3 tree. Why would you lay them over the tree branch? 1 bun, 2 shoe, 3 tree, 4 door, 5 beehive, 6 stick, 7 heaven, 8 gate, 9 swine, 10 hen. Think bun, shoe, tree, and you see their associated images. Carrots, milk, paper towels. Let's do it again. Bun, shoe, tree, and then images, carrots, milk, paper towels. How do hierarchies aid retrieval? When we organize words or concepts into hierarchical groups, as illustrated here with some of the concepts from this section, we remember them better than when we see them presented randomly. So we do this all the time when we make mind maps or any kind of graphic organizer. How can the spacing effect impact memory retrieval? The spacing effect is the tendency for distributed study or practice to yield better long-term retention than is achieved through massed study or practice. Basically, massed practice cramming can produce speedy short-term learning and a feeling of confidence. But to paraphrase Ebbinghaus, 1885, those who learn quickly also forget quickly, which is why I'm constantly telling you to chunk up your study guide and space it, which is why it's spaced out on your checklist so that you're not cramming the night before to do it. Think to yourself, do you actually do that? If not, what changes can you make so that you can practice distributed practice versus massed practice, which will produce long-term better recall, which will ensure that you have less stress going into your AP exam. How can the testing effect impact memory retrieval? One effective way to distribute practice is repeated self-testing. It's a phenomenon that researchers Roediger and Jeffrey Carpike have called the testing effect. Testing does more than assess learning and memory, it improves them. So a way to impact your memory retrieval and to practice instead of massed practice, to do distributive practice is to repeat self-testing. 2 levels of processing are shallow and deep. Shallow is encoding on a basic level based on the structure or appearance of words, whereas deep is encoding semantically based on the actual meaning of the words. Tends to yield the best retention. So why do I have you with psychoblurbs? Define and apply it, because applying it is going to give you a deep processing versus a shallow processing. And moving into the end of our lesson, most people excel at remembering personally relevant information. Asked how well certain adjectives describe someone else, we often forget them. Asked how well the adjective describes us, we often remember them. This tendency, called the self-reference effect, is especially strong in members of individualist Western cultures. This is also why when you're making applications and when you're coming up with applications, it's really helpful to make it personally relevant so that it is more of a deep level processing. And look at me, I kept it under 20 minutes. Woo!